Welcome to Mathematics with Tom. I am Tom, and today we're going to look at where we left off in our last video, where we solved this problem. We said the solution, if we have the second order equation, y double prime plus omega squared times y equals 0, then the null solution is equal to some constant c1 cosine of omega t plus c2 times the sine of omega t. Well, now here's what's interesting. Let's give it some initial conditions. So I'm going to come back up here, and we're going to actually have an interesting surprise. The first one is what you might expect. Well, what happens at y of 0? I mean, where is the system starting? So let's plug this in. So y null let me do it this way. So first off, y null of 0 equals c1 times the cosine. Well, that's just to me the cosine of 0 plus c2 times the sine of 0. Well, what happens? Sine of 0 is 0, so this tells me that c1 is equal to whatever my initial condition is. I probably shouldn't have that little n in there. Let's clean that up. Okay. Now, but notice this, we still haven't figured out what c2 is. And that leads us to the next piece. And that is, when you have a second order differential equation, you actually have two initial conditions. You have y of 0, as we've been studying for first order. For second order, you pick up y prime at 0. So this could, if y prime of 0 is 0, it means there's no initial velocity. If y prime of 0 is something other, it means that the system has started with some imparting velocity on it. So let's see what happens for y prime of 0. Well, first off, let's take the derivative of y null. So that's going to be a minus omega c1 sine of omega t, because I'm taking the derivative of the cosine, plus, then I take the derivative of the sines for the second term. Well, that's going to give me an omega c2 times the cosine of omega t. Well, now let's substitute in our initial condition. So y prime at 0 is equal to minus omega c1 sine of 0. And I could have put c1, we could be using y of 0 in there now, plus omega c2 cosine of 0. Well, the first term, this becomes 0. So now I'm left with y prime of 0 is equal to omega times c2. And so we can say that y prime of 0 divided by omega is c2. So let's rewrite our final solution. So our y null, our null solution is now c1, which is y of 0, cosine of omega t, plus our next piece, it's going to be y prime of 0 divided by omega times the sine of omega t. And that is our y null for any set of initial conditions. But remember, what we've been doing is we've been writing, if we have a sum of sines and cosines, we can write this in some form, y null as r cosine of omega t minus some other angle, and we call this the phase leg. So alpha is the phase leg. It's the difference between the cosine and sine going in and then the cosine and sine coming back out. So how do we write this? Well, if you recall, what we said is we said that r is equal to the square root of y of 0 squared plus this next one is going to be y prime of 0 divided by omega, that whole quantity squared. And that is r. And then, so our final step, though, is what about alpha? Well, remember that alpha, the tangent, that's right, this way, tangent of alpha equals, well, it's the opposite over the adjacent. Well, the opposite is the coefficient of sine. So that's going to be the y prime of 0 divided by omega. And the adjacent, that's coming from the cosine, so that's y of 0. And this really cleans up more nicely to being y prime of 0 over omega times y of 0. And now we have written our null solution in this form of r cosine omega t minus alpha. And remember, so we could put all of that in there. That's going to look pretty rough. And so alpha actually is the arctangent, arctangent of y prime of 0 over omega times y of 0. Okay, in our next video, we're going to find out how do we graph our cosine omega t minus alpha. I hope that helps, and thanks for watching.